Okay, well, I'm very sad that I'm not there in person, uh, but thank you for allowing me to present today. My voice is a little bit hoarse. We'll see how it holds up today. Anyway, this is my normal status of embedded Linux talk. It's been updated for June 2024, and let's see here. Make sure I get on the right. So the nature of this talk, I periodically take a look at the status of embedded Linux. And this is not comprehensive, just a few of the things that I saw. Obviously, there's no way to cover everything that has happened in the last 3 months or a year. And so I'm sorry if I missed something that you're interested in. Hopefully you'll find some information in here that is useful. In particular, talking about latest kernel features that you might want to use in your products. So this is the major outline, the Linux kernel, technology areas, industry news, community, and then some quick conclusions. In terms of the Linux kernel, we're now on 6.10 RC5, release candidate 5. So we had the 6.9 release in May, and you can see the previous releases were very consistently having either 9 weeks or 10 weeks for a kernel release. We expect 6.10 on July. Of course, we've already had the merge window, and so we kind of know what's going to be in it. So we'll talk about those. I'm going to go over these relatively fast because I covered this in March, but in 6.5, we had some interesting boot time stuff related to reducing the boot time to parallelize bringing up CPUs. Currently, as of March, that was only on x86. I haven't seen any update on that. There was a big reorganization of 32-bit device tree files, the directory structure, basically to match the same directory structure as ARM64, MIPS, and RISC-V. We also had miscellaneous ftrace and perf updates. We seem like we have those all the time. In October, we had the 6.6 release, and you could build the kernel without bufferhead support. The only reason to kind of pay attention to that is that if you have a really old file system that depends on the buffer cache, that buffer cache might be deprecated in the future. So something to watch for. There's the new Event FS subsystem that improves the memory efficiency of the tracing subsystem. And there was also shadow stacks that in the 6.6 release were only on Intel. So I've talked about these before, but shadow stacks is a really nice feature for security to detect return-oriented programming attacks by putting the return address on a regular stack and on a shadow stack. So it's harder for to be taken over or overwritten. Some hardware actually can manage that shadow stack for you. So it makes it more secure and actually faster. But in any event, that landed in 6.6 and patches for 64-bit ARM and RISC-V were in development. And also patches for Musil C library. In 6.7, this was in January, you can enable or disable 32-bit emulation on an x64 kernel, so 64-bit x86-based kernel. That allows you to reduce the attack surface, obviously at the price of not being able to support old 32-bit binaries, but you may or may not have those around on your system. IA64, the Itanium architecture was removed. There was more efficient kernel same page merging, and PrintK now supports per console locking. And I believe this was something that came from the real-time project. They're still working on real-time issues with PrintK. In 6.8, we had the deadline servers feature added that prevents real-time tasks from completely starving normal tasks. We had the first real Rust driver added to the kernel, and that was a reference driver for ASICs PHYs. And then the networking core data structures were refactored for better cache efficiency. So TCP performance in sub situations improved up to 40%. the slab memory allocator was removed. Okay, so that was kind of a big deal. There's now only one memory allocator, well, object memory allocator in in the kernel, which is slub. I'll talk more about that later. And then the perf data type profiling was added. I want to talk about deadline servers really quickly. So there was an issue with the way that real-time throttling was happening. There was a real-time throttling feature. You don't want real-time tasks to be able to starve your regular tasks. If you give too much of the CPU to your real-time tasks, then your regular tasks don't get any CPU at all, and that can cause hangs or lockups. But the old throttling feature actually spent a fair amount of time at idle. It kind of forced the CPU to waste some cycles. So now they have a deadline server, is what they're calling it, and it's a special process that runs at deadline priority, which is higher than real-time priority. But it only starts up and starts running when it sees that starvation is detected. So it actually, and then it has a guaranteed quanta or quantum. And so this is a much more efficient way to handle that starvation case. The other thing that was in this release was perf data type profiling. Very interesting feature, subcommand to perf, where you could actually get samples of the accesses per field in a data structure. So you could see how the data structure, what the cost was in terms of the data structure, how often it was accessed, and whether or not you were getting, in particular, whether you were getting cache hits. So you could tell if a frequently accessed field was in a different cache line, and and so by doing that, by looking at that, if you rearrange the structures, fields in your structures, you can actually get better cache performance. So basically, a really handy tuning tool. Also in the 6.9, we saw that the ext2 file system was marked as deprecated. For those of us who have been around for a long time, we still remember ext2. So I don't think we probably have very many embedded devices still running that file system, but they're still supported by ext4, but the driver is now gone. And then there's a faster timer setup. It turns out that most timers in the kernel never expire. Most timers in the kernel are used to just as backups in case something goes wrong. So in the normal code flow or execution flow is that a timer will either be canceled because the event was successful, or it will be reissued again, possibly because the event was successful. But they almost never expire. And so they were noticing that there were some operations that were happening that were not needed until the timer actually expired. And so they got rid of those. They changed it around. It had to do with selecting which CPU to run on. They don't do that on timer creation. Now they do that. They select the CPU when the timer fires. And since that doesn't happen very often, it actually reduces the amount of overhead to do timers. So it always amazes me when they find these optimizations for code that's been in the kernel for decades. Anyway, they also work on reducing network stack contention. The kernel energy model can be updated at runtime. And there was a mitigation for a vulnerability on the Intel Atom known as register file sampling. So we continue to see security fixes. And then the 6.10 kernel, as I said, we've already had the merge window. So this is expected in July, probably mid-July. Continued improvements in Rust support. There was something I saw that was interesting, this encrypted interaction with TPM. So if you have a TPM, that's a security module that holds keys and secrets on your system. But most of the APIs to that I think were in the clear. There's now mechanisms so that you can actually communicate with your TPM over a secure channel. So that's kind of nice. And then cryptostats was removed. Okay, so you see things go into the kernel quite often, but someone looked and did a big analysis. They scanned all of the applications they could in like all of the major distributions, Red Hat and Debian and SUSE, and they said we can't find anybody who's using these stats. Um, their stats having to do with the performance of the cryptos things, and they said, well, if no one's using the stats, they're causing runtime and maintenance overhead. They were kind of a pain. And so they said no one seems to be using them, so they actually just yanked them out. So that simplified the crypto code and actually sped up the crypto code a little bit. And then in the category of kind of nostalgia or sad things, removal of the early alpha CPUs. So I'm going to talk about this. So the very early alpha CPUs, these were the first non-x86 architecture that Linux was ported to. This was John Mad Dog Hall worked at Alpha, and he was one of the very first designers who got in and said, hey, let's use Linux on non-x86. And so they actually provided some Alpha CPUs to Linus. But those early Alpha CPUs did not provide byte-level memory access. They were kind of funky and weird. And so Linus said, well, he said, we got to get rid of this. It's too hard. It kind of gums up the support for these this architecture that doesn't support byte level memory access it causes all kinds of weird exceptions that have to be worked around. So he said, well, it's a bit sad to see the support for my first alpha go away. This is the part that kind of struck me. If you want to run museum hardware, maybe you should use museum kernels. I was like, oh, okay. So if you have hardware that's not out there, it's not being used anymore, you can't run it on a modern kernel. And the upstream is okay with that. So it's a bit troubling, but it's understandable if it's causing maintenance issues. The other thing that is coming in 6.10 that's been documented is memory allocation profiling. And so this is actually pretty cool also. This is not the same as that that perf tool that was per structure. This is looking at all of the memory allocations that the kernel that does through the life of the kernel, and it tracks which code did that allocation, right? So there's a lot of in the past this at the time of a call, you know who the caller is, but it's not recorded anywhere. So this is a way of being able to record all of the everybody who allocates memory, and you can actually see, well, what are the functions, what are the drivers in the kernel, how much memory are they using? So it gives you very detailed information about memory usage. So this is going to be really useful for debugging memory usage. So now that this is upstream, I think we'll see a lot more memory tuning in the future. So people will start looking at their drivers and saying, well, how can I reduce the memory usage of this or that? So, and it's actually already upstream, so you can, well, you can look at it online in documentation, allocation profiling.rst. So something I want to talk, I don't usually do this, but I'm going to talk about something that could be coming even in the future. So there's a patch set that's been flying around actually for over a year now called the Extensible Scheduler or SkedgeX. And this is an implementation of some APIs in BPF that allows someone to write a BPF module to implement a new scheduler and install it at runtime. So Linus kind of watched what was going on with this and said, you know, there has been debate about these patches for quite a while, but he said there hasn't been any movement for like 9 months. He says if no one, you know, we can't just let this thing sit there. There are companies that are pretty interested in it. In particular, the people who have these kind of funky special workloads, Facebook, you know, cloud servers basically have these specialized workloads, and they really want to be able to have high configurability of the scheduler. And so there was some debate on the mailing list. You can go look at this thread. It's a pretty interesting thread. And a request for a 3-month delay while they resolve some issues, but we'll see what happens there. Linus was pretty strong in his assertion that he wanted to get in at 6.11. He did actually say he could hold off a release if there was good arguments, but some of the arguments were didn't seem to be convincing him. Anyway, um, okay, so we all know about long-term supported kernels, right? So LTS used to be supported for 6 years, and now it's only maintained for 2 years upstream. And that's causing a lot of companies some concern and a lot of organizations some concern. So there's actually been a couple of things going on there. So I don't know if you heard about Linaro was working on a new LTS support option. And I know that Motai-san and others have formed a LTS study group. And I believe, if I understand correctly, you guys are having a meeting later today as part of this Jamboree. So make sure you give us a kind of a report of what your discussion is and what's going on there. So these are the kernel releases just real quickly as of June. You notice we're in 6.10 RC5 and the latest long-term release is 6.6, but there's several of these. So several of these are going to start to drop off, these older ones. Well, let's see. Yeah, so look at how many of these are going to expire this month. I think they saying that. Oh no, that's the last changelog. I can't remember if that's the date. Oh, that's the last time they were released. But some of these are going to stop being supported fairly soon. I think the 4.19 and 5.4. Anyway, so we'll see what happens there. This is just a quick update on contributions by some of the major or embedded Linux companies or organizations. A lot of these are in Europe, but you have like Bay Libre. This is commits since June 2023, so this is about a year's worth of commits. You see Bay Libre has been working on SPI stuff and ADS 82S 1210 driver. Miguel Reynal at Bootland. Bootland's been doing a lot of patches, working on MTD and NVMem and Mac 802 15.4 driver. Collabora is doing a bunch of GPU work. Ideas on Board has been doing a bunch of camera work. Igalia is also doing a bunch of GPU work. They've gotten a lot of good stuff upstream. Linaro, of course, comes in with just this crazy number of 4,000 patches. Most of that is Christoph and has to do with device tree, but they're doing a lot of upstreaming work on sound and Samsung clocks and other things. And then Thomas Gleixner for Linutronics doing Preempt RT and Print K and timers, and of course x86, general x86 support. And then another kind of super developer is Uwe Klein-Koenig, who's doing driver cleanups. And he had 1,900 patches for Pengutronics. Most of those were really simple. He removed a callback that was returning a void. So he had a cleanup that affected like thousands of files. And then you have Toradex and Wind River also doing some good work there. So that's just kind of gives you an overview of the types of things people are working on upstream. Okay, so that's the Linux kernel. And so now I'll talk about some different technology areas. So we just had Embedded Linux Conference ELC 2024 in North America, and that was in April in Seattle. And so I have a lot of items in here that are where I refer to the presentation. I didn't put the slides and video links. There would have been links everywhere. But I do have the title and the presenter name. So if you want to look something up, just go to this page, and it's pretty easy to find. If you go to the eLinux wiki, you can search for it, or go to embeddedlinuxconference.com. Also has a link to this page. So that's if you need to find slides or videos you want to follow up on, look at something. So a couple of the talks, there's been a renewed interest in boot up time. There were actually 3 talks on boot up time at ELC. There's the Suspend a RAM talk by Gregory Clement from Bootland. He talks about the trade-offs in boot speed and power usage while suspended. And I guess in automotive, TI was also showing a demo of a Suspend a RAM solution at the exhibition at ELC. So yeah, if you it's really really hard to get Linux to actually boot quickly, but you can unhibernate or you can resume from RAM pretty quickly. But it does require that you have power to your RAM because it's often it's DRAM, it's not something else. Um, but anyway, another talk on boot time was this deferred memblocks in it for boot time reduction. So this was an interesting one from Qualcomm. Basically, looking at can you get through the full boot, or how much overhead is it to boot like your entire memory space? So this you can imagine this was mostly for like phone stuff, where they had 64 or even bigger 64 gig of memory, which is not the normal case in embedded. But but he looked at like, what is the actual time to do that? And there's a fair amount of time. I think it was 200 milliseconds or something. Anyway, so he had a system where he could initialize the first 1 or 2 gig and then bring up the system, get all the drivers initialized, and then initialize the rest of memory later. And then the other talk was software optimization for early Linux boot for time critical applications. Okay, so this is again, TI has been doing a lot of work here. They showed up at Plumbers last year talking about pre-initializing drivers from the firmware. This particular talk talked about optimized loading of the kernel image, turning on DMA, and having the firmware be more intelligent about how it loaded the images, and also what the effect of different kernel config options and file system optimizations, how those affected boot time. And you can shave 50 milliseconds here, 100 milliseconds there, and pretty soon it starts to add up. So in the core kernel, there has been, I think this is just a proposed patch. This is not one that's actually been accepted yet, but it's a generic ring buffer for the kernel. So this is a ring buffer for communicating with user space. And it's like, hey, don't we have those already? It's like, oh yes, we have many. So the ftrace has a ring buffer. Obviously, IO you no, I can't remember. The IOU ring has a ring buffer there, and Netlink has a ring buffer. There's a whole bunch of ring buffers in the kernel, but they said, well, we need one that's unified. We need one that handles all the use cases. Okay, so maybe this one will make progress. It was really funny actually in the LWN.net comments about this. They said, "Oh, you missed a chance to use this one title related to Lord of the Rings. Like one ring to rule them all." And John Corbett said, well, actually, I already used that title in 2010 for a ring buffer submission. So it's like, okay, 14 years later, here we're still trying to unify the ring buffer implementations. And also see also the XKCD comment. This is a famous XKCD cartoon that talks about, proposing a unifying standard, and then all of a sudden you just got another standard that you just added to the number. In terms of graphics, so GPU work, Collabora continues to do a whole bunch of great GPU work. They worked on the Mesa 24 release, and they have support for Panfrost, Zinc, NVK, and a bunch of other details there. You can look that up. And then Igalia is doing a bunch of GPU work on Raspberry Pi. They've done it for a bunch of other processors as well, but they seem to be the ones. I suspect they're getting paid by the Raspberry Pi Foundation, but I don't know. Maybe they have customers that are paying for this, or other customers that are paying for this. But this talk has a really good overview of the Raspberry Pi upstream driver work. It turns out that the Raspberry Pi has a couple of different things with its GPU from the Raspberry 3 and 4. And so it did require a fair amount of work. And it was interesting. They talked about having to do a bunch of work with a simulator before they actually got hardware. So that's interesting, I think, that but the driver that they have now is supposedly Vulkan 1.2 and OpenGL ES 3.0 conformant. So that's really good. In terms of graphic frameworks, there was some kind of worrying news. So we're some news that made us worry a little bit. That Flutter. So Google laid off the Flutter development team, and then after those layoffs, it was part of a general round of Google layoffs. So I don't think they targeted them specifically, but they just anyway. But 2 weeks later at Google I/O, after the layoffs, there were a bunch of Google developers talking about Flutter at Google I/O. It's like, okay, that's a mixed message. And they announced all these new features and new customers using Flutters. In particular, they announced that LG has is putting Flutter on all of their future TVs on WebOS, which is a Linux derivative, right? Um, Linux distro. Anyway, so there's a bunch of news if you want to see what's going on with Flutter. One thing I just stumbled across, which I thought was really interesting, was they actually talked about in this Google I/O set of talks about Flutter on the ability to develop casual games. And it turns out people have what they really meant was kind of 2D games, but people have gone in and of course put in ray casting for kind of pseudo 3D games, and you can play the equivalent of Castle Wolfenstein. So you go out to this GitHub and there's a thing called Flutterstein 3D. So people are still doing a lot of work with Flutter. I actually hope this is the framework that's being used by Toyota on AGL. To replace Qt because Qt has licensing problems. And so I really hope that this kind of becomes popular. I think it would be good if we had a really nice, solid, well-supported graphics framework for embedded. One thing I will note also that's interesting is that I went to the Flutter website and the Flutter developers say, yeah, there are more community contributors to this than there are Google contributors. So that's actually a really good sign. So even though the Flutter dev team got laid off, the work on Flutter continues. In terms of file systems on I/O, we had the block I/O speedup that was added in 6.9. It turned out to be there were these time stamping operations that were happening. People were inside the block layer. You have to grab the time while you're issuing the I/O. It turns out that they were doing it like a lot, like really frequently, right after each other. It's like these, operations are going, thousands, hundreds of thousands of times per second. And they said, well, so they now have a system where they cache the time so they can do that time lookup really fast. And this is something that I think it was Jens Axpo said that, or I don't know, whoever the developer was, he said, yeah, that has been in the back of my mind for a long time. It was like a really quick fix and it gave me a 6% performance improvement. It's been sitting there for a long time, kind of in his head. So, they continue, like I said before, they continue to make speed ups in sections of the kernel code. There was a talk kind of related to file systems and I/O, kind of more about the MTD layer, but maximizing SD card life, performance, and monitoring with Krill Counter. So Andrew Murray gave a really nice talk about SD cards and NAND flash hardware and software. And basically, you have these problems with NAND flash that you have write amplification. And so that can really, when you're writing to NAND, certain patterns can really slow it down over time, and actually can wear it out faster. And so there's a need to measure at the block layer and optimize. And he actually has this program called Krill Counter that allows you to do some of that measurement and shows you some good stats and stuff. It's pretty good. There's lots of charts in this presentation that shows, he did some kind of life cycle testing to see how long he could drive certain flashes before they died. So, measured it by wearing them out. And then in terms of networking, I didn't see a whole lot of new technology development. There's always kind of crazy stuff going on in the data center networking stuff, optimizations and things like that. But here's two talks that were given at ELC 2024. just mastering Ethernet drivers, and then Bluetooth on embedded systems deep dive. So these were really good talks. If you're riding a driver or you're just new to those particular areas of the kernel, these were pretty good talks to bring you up to speed on that area. Preempt RT. Well, no surprise here. It's taking longer than we thought. I think we're going, I don't know how long we're going. It's at least 14, 15 years. Uh, but it is kind of slowly getting upstreamed. I didn't have the number of lines from last time, but the count here, the line count is 2,900 lines, about 80 files, about 100 patches, which is a fairly small number of patches. But it keeps going down. It was, I think, the last time I checked, it was 120 patches, and in a couple of different areas. So this TTY serial patches that have been hanging on forever, they're actually upstream now. So the big one that we're waiting on is those print K patches. There's about 46 patches for print K. And then there's some miscellaneous ones, like the ones for ARM, PowerPC, and RISC. There's about 5 or 10 each. Not a huge number of patches. So and that last bullet there, I still think this is not a great way to get RT. I actually like the Zenemai approach better. But it seems to be working. People are using this in production, and it's not that hard to apply the patches, but it'll be even easier when you don't have to have like a separate tree, right? I think there's so many projects that have the regular kernel tree and a real-time tree, multiple kernel versions. So it'd be nice if it got upstream. In terms of security talks, there was this good one by Marta Rybczynska talking about patterns and anti-patterns in embedded development. So she went back over some of the kind of the shocking security incidents in 2023, and this one, the XZ, was that XZ or XD? I think, anyway. Anyway, some of these are pretty shocking. So there was a train that was geo-locked by the supplier. So the supplier had actually put on the train. This is not like a toy train. This is like a full, a full-size train engine, and I think it was a passenger train. But anyway, that they had snuck this back door in that made it so that the trains would not function if they were not in a particular area when you went to go do maintenance on them. So they were trying to prevent the owner of the train, their customer, from getting a third party to do maintenance, which is like terrible. That's a terrible thing, right? It's totally underhanded. But this is the type of thing that should have been caught in code reviews. So in terms of delivering the software, when the supplier delivered the software, they should have caught that, or the customer should have caught it. Anyway, the code that did this was I mean, it was not obfuscated or anything, so they should have caught it. An HTTP/2 denial of service attacks. This one was an interesting one because it turns out that it had to do with accepting lots and lots of HTTP connections. And because in the embedded world, a lot of times the devices have kind of small numbers of connections that they support. So they're actually more frugal they're more careful with how they allocate connections, and they were less exposed to this attack. There was a company that had its signing keys were not secured very properly, and they were just on someone's machine. And so there was a ransomware attack where the malicious actors got the data off someone's machine, and it happened to have the signing keys in the clear, right? They weren't encrypted, so it's like, oh, that's bad. That's bad practice to not have physically secure encrypted signing keys. You don't just leave them lying around on someone's machine, even though, I mean, it was inside their firewall and everything, but just like, these things happen. You just can't trust. And it's bad to lose your signing keys. Really, really bad. And then the XEUtils backdoor, I think everybody knows about that one. That was a really, really big deal. I probably should have put it. I thought I had done this last. Maybe I didn't cover that one. I should cover that one in a future talk. But this is one where the developer got. I'll just talk about it. I don't have a slide on it, but I'll just talk about it. If you haven't heard about this one, there was a developer who got onto this project, which is a compression tools project and a compression library, and worked for over 2 years um, on the mailing list and participated and eventually was granted maintainer privileges. And when the maintainer went on a break, the core maintainer went on a break, this guy snuck a bunch of secret junk in, very very stealthy and very tricky. The way the stuff that he did, the goal was to try and get the way it worked was it allowed him to take control of a machine, get root access, uh, because these compression libraries were used by systemd. So, and systemd is the init process runs as root. Anyway, but very, very tricky stuff. And luckily, it was detected by an observant um person who was testing SSH and doing some stuff. And so that was, yeah, basically it was for taking over SSH connections. Anyway, so those patterns are kind of interesting and useful. Another security talk was about signing of boot images. So in this case, TI talked about some of the complex issues, especially when you have a complex boot architecture. There's a lot more trusted elements on different processors. It's no longer just a single processor running through, multi-stage bootloaders. There's trusted bootloaders and untrusted bootloaders and signature checks and all this stuff. And so there's this binman tool that's been around, and they talked about how you could use that for signing binary images and how they modified it specifically for the TI boot architecture. And then the last one on security was engineering secure SSH access for engineers. So obviously, it's super handy if you're a support engineer, if you can get SSH to, you can get a remote shell on a product to help a customer out. But that's quite dangerous to leave that in there. So the best security is to remove SSHD, but then your remote support is hard. So he talked in this talk, Colin talked about kind of best practices, what you should do. He said you should not use passwords or public keys or PAM authentication. There's a bunch of issues with that. If you have millions of devices, how do you uniqueify the public key and that type of thing? But he recommended use certificate authentication. He describes how to set that up. So maybe you can leave secure shell on your products and still have it be secure. So I'll let you look at the talk and decide for yourself. Okay, and then the kernel community. So these CVE handling. So the kernel community became a CNA, which is a CVE numbering authority. Yeah, certified number authority. I don't think that's right. Anyway, that means the kernel, there's a group of kernel engineers. There's 3 kernel engineers who can do the CVE assignment. Instead of letting an external party do the CVE assignment, it's done by the project itself. So other projects have recently become CNAs. glibc, curl, and Python are 3 of them. So this is good. And there was a status update on this that just came out. There have been some complaints about this because now the kernel is producing way more CVEs than it used to. And there were a lot of the distribution vendors who were saying, hey, now we're swamped. And he said, used to be we'd only get, so many CVEs a month or something, and now we're getting like hundreds. And the reason is that so this produces many more CVEs than the old process. The old process was ad hoc. So we weren't seeing a CVE for every security bug. We were only seeing ones for the super severe ones. The actual CVE policy is you're supposed to have a bug for every, or you're supposed to have a CVE for every security bug. So a lot of people are saying, "Oh, you're doing a CVE for every single patch," and they say, "No, that's not true." And there was an article. In the article, you can read about the developers, in which they actually have a process that they use to decide if a patch that's going into the stable tree is a security patch or not. So but the distro vendors are kind of complaining because they're swamped. They're saying there's not enough CVE filtering. It turns out the CVE filtering is quite difficult. The openness of the kernel, you can use the kernel a lot of different ways, and so what may be, the distro vendors are saying you're sending a bunch of CVEs up that are like that no one could possibly hit, and they're saying, well, you guys are looking at enterprise distros. You're not looking at embedded, or you're not looking at these other categories of use your mobile, and so um, it turns out that it's really costly to do in-depth security analysis, and so there's some argument about who should be doing that. Upstream doesn't have the cycles to do it. The OS vendors who are offering support, maybe they should be doing more on themselves, and they're just saying, well, hey, we want to collaborate to make it easier. Okay, so that's security. So system size. So the slab memory allocator was removed, and slab was removed in 6.4, so only slub remains, SLUB. So there is a config slub tiny option for small systems, but I just think in general, Linux has given up on super tiny systems. Now, having said that, I actually found a super tiny system that can run Linux. This is the lowest priced processor I've ever seen that can run Linux. There's a 15-cent processor that you can get. It's a RISC-V processor, and for obscure reasons that are hard to describe, it's actually a RISC-V processor running a RISC-V emulator. I won't get into why they're doing that, but it runs very slowly. Okay, so this is not production grade material here. It's a 48 megahertz processor, and they're doing some emulation on it, but it's 15 cents, and it has 8 meg of SPI NOR and an SD card. I don't think the SD card's in that. Just the processor is that cheap. Anyway, so there's people doing crazy stuff with Linux, but I think Zephyr, the mood I'm getting from the industry is that Linux people are saying, let Zephyr have the low end, or some of these other RTOSes. Sony's using NutX, and there are other people using stuff. I think it was Facebook is using no, yeah, and Amazon is using free RTOS. Okay, so now moving on to testing. So there are a couple of interesting talks on testing rotation sensor drivers with Lego robots. The reason I highlighted this one is because you don't often see physical hardware testing. So you see a lot of testing on, you might see testing on boards, but you don't actually see testing of like the peripherals and like the sensors and the buses and things on physical hardware. In the embedded space, they do some of that in enterprise, but it's like drive hardware and stuff, and fabric hardware. But anyway, this one was interesting. They used Legos to physically rotate some items and compared the sensor results to detect driver bugs. So that was interesting. And then Paul Wisuzorek, or Pavel, yeah, I missed an E in his name there. From Collabora, he actually compared a bunch of different automation systems. So he compared Lava, LabGrid, Board Swarm, and Beaker, and I think there was one other. These are kind of more board farm management or board management systems than they are exactly CI systems. So, kernel CI famously kind of sits on top of Lava. But so if you want to see kind of the use cases, he talks about the strengths and weaknesses of each of these and where you might use them. So that's testing. So now in terms of tool chains, so GCC 14.1 was released in May. They have a bunch of stuff. You can go look at kind of the details there. If you look at the release notes, I thought I had a link to the release notes, but you can find them if you Google it. There's a new -F hardened flag to enable security hardening features. There's improvements to the vectorizer, and in particular, there's improvements in the static analyzer. And that means that it's the code will find the compiler will find kind of more bugs in your code at compile time. So, um, and I put this on here longer. I can't remember some of the details, but you can look it up. There's an article. There's two articles here. You can go look at the new static analyzer features. In terms of LLVM was also released relatively recently, 18.1. And they have support for new RISC-V extensions and new ARM processors, better support for C++ 23 and C23. That was the same is true of GCC. Also had support for C23. And people are using LLVM for whole distributions, not just the kernel. So I think that's interesting. I think I've talked about this. This is a really good resource by Bernard Rosenkranz of Bay Libre that he gave actually last year. So it's probably time to age this slide out. But if you want to kind of see the different options and try, GCC versus Clang versus TinyCC, I would recommend looking at this talk. But this is not from ELC 2024. This is ELC 2023. And then this is something I found that I thought was really cool was you can actually get tool chains, pre-built tool chains from Bootlin. Linaro has had pre-built tool chains, or you can, of course, build your own using Yocto Project, or I don't know if Buildroot allows you to build your own tool chains. But if you want some pre-built ones, especially if you want old pre-built ones, right? Sometimes it's hard to go back and find a tool chain. This is something I needed to do. This is how I stumbled on this, was to find a tool chain for a super old Debian distro on one of my boards. So that's just a resource to make you aware of. In terms of tracing, there's always some crazy stuff going on with tracing. BPF tracing performance. People are talking about refactoring uprobes. And just some tweaks to how the instructions are overwritten and how the calls work once they're instrumented. They can result in a 250% tracing performance speed up. But some of those techniques are Intel only, so it's been kind of highly optimized for Intel. And then BPF, turns out you can capture stack traces asynchronously, so a lot more tracing functionality is going into BPF, and they're looking at performance of that. I'm not a huge BPF fan myself. I think it allows a lot of kernel code to be kind of not upstream, and so. But I think the tracing stuff is pretty safe. I mean, BPF was originally written for networking filtering, network packet filtering. I mean, that's what it is, Berkeley packet filter. Using it for tracing seems okay, and I guess in 6.11 we're going to start using it for schedulers. So. I don't know, BPF, lots of stuff going on. The other thing going on with tracing is there's user space accessible ring buffers. You can mmap ftrace buffers into user space. And that reduces the number of data copies, so that's a performance enhancement. And then this is something I saw. I don't know if this has actually been, can't remember, the user ring buffer thing, that was actually committed. I got the commit ID there. But the kexec allows preservation of ftrace buffers. So there's something called a kexec handover, where the kernel is booting into another kernel. You're kind of using a kernel as the bootloader for itself. And this is used a lot on cloud servers and stuff, but you could potentially also use this for debugging embedded machines, because they have a way to preserve your ftrace buffers over that reboot. So if you have a kernel that's causing problems or it panics or something, but you have the ability to hop into kexec and reboot the kernel, there's a way you can preserve those ftrace buffers and then go look at them afterwards. And there had been some mechanisms to do stuff like that in the past, but I guess this is a little bit cleaner than some of the other ones. Other ones required you to the protected RAM file system, you had to reserve some RAM memory, and this one is a little bit cleaner than that. Build tools. Oh, okay, so we had the Yocto project just had their release in April. Their new release is 5.0. It's called Scarth Gap. I've actually used this myself. I was doing some Yocto project stuff. Anyway, this is going to be an LTS release. I think they do an LTS release every 2 years. They have support for a generic ARM64. They default to a 6.6 kernel, but of course you can put your own in there. There's a new tool called a BMAP tool that does more efficient image flashing, and then tons and tons of features, packages they've added and packages they've updated and stuff like that. So go check out the release notes on that. And then this is something I stumbled across. I don't know, maybe this is not earth-shattering, but I thought it was kind of cool. There's this application called Raspberry Pi Connect, and it supports web-based remote GUI. So Raspberry Pis have run VNC before, and you can connect with them over VNC protocol. But this runs a kind of a web server on the Raspberry Pi that supports VNC running over WebRTC. So a lot of places won't, a lot of firewalls won't let you let VNC through, but you might be able to get WebRTC through because that's what's used by Zoom and other teams and other what do I want to say? Video conferencing apps. It also supports remote shell. So all you have to do is point a browser at your Raspberry Pi, and then you have full GUI and shell support. So that's pretty cool. And that just came out like a couple months ago. So it seems like an obvious thing to do, but and hopefully this will be usable. I assume it's open source and that people will be able to use it on other platforms as well, but that's kind of a neat little thing. Okay, so some industry news. The Cyber Resiliency Act, SFC versus Video, HDMI Forum, and Linux on Mars. We're going pretty quick here. I hope I don't remember how much time I had, but I'll be done relatively soon. So the CRA, the Cyber Resilience Act, this is coming out of the EU, and it's a mandatory cybersecurity framework. So there's a lot of new regulations about how secure your code has to be. People are kind of tired of stuff getting hacked and these exploits and stuff. But anyway, security updates will become mandatory. And you'll have to do security updates for 5 years. Okay, so that is imposing a lot bigger burden on software than it has in the past. So there's due diligence of all components and products, documentation requirements. A lot of this is what's driving the interest in SBOMs. There's mostly self-assessment, but some categories of products require actually a third-party assessment. So, and it extends the CE marking. So in order to get products into Europe, your products are gonna have to be conformant with this Cyber Resilience Act. And so companies are still working out how they're going to deal with all this. The final publication, it's not done yet. So it's supposed to come out on October 24, and then have a full application in 2027. So you've got kind of a 3-year period here where companies can make sure that they're complying with it. But that's something to be watching. And then this is just a legal case that I'm watching. This has to do with TVs, and Sony does TVs, so we're kind of interested in this one. But the Software Freedom Conservancy sued Vizio, which is a TV manufacturer, and the reason this is interesting over a GPL violation. Sorry about that. Anyway, but they're asserting something really different. They're asserting what's called a third-party beneficiary right. Normally, the GPL, people have always assumed that the GPL was a license and it could only be enforced. You could only have standing to sue if you were the copyright holder. And they're saying they're not the copyright holder, but they think they're allowed to bring a lawsuit anyway. And that is if the judge or the jury rules in a certain way, it would allow any third party to come in and enforce the license, and it could be lawsuits galore. So we're kind of watching this one. Anyway, the latest update on that one, I talked about this before, but the latest update is that Vizio and SSC both deposed the Linux Foundation. They're in discovery right now. We'll have the trial later in July. So just coming up in, I think, about a month now, we'll have the trial starting. There's a lot of lawyers watching this. I know a few lawyers who are going to be who have said that they're actually going to go and see what happens in the courtroom. And then a random note, this is new information. I don't know if Walmart knows what it's getting into, but Walmart is actually in the process of acquiring Vizio. They've announced an intent to acquire Vizio. So I think Walmart's trying to get their own TV line. Uh, and who knows? I assume that they know they've got this lawsuit pending. So that's kind of a weird wrinkle. The HDMI 2.1 HDMI forum told AMD that it can't make open source driver for HDMI 2.1. This is an old problem that always comes up. Well, it doesn't always come up. It's less frequent, but it's kind of annoying to see this type of thing happen. So there's an HDMI 2.1 specification, and in order to see the specification, you have to have a non-disclosure agreement, and the non-disclosure agreement kind of precludes you making an open driver. And it's like, it's kind of ridiculous in this day and age that the forum thinks that's the best way. I mean, like literally every device I can think of that has an HDMI 2.1 is connection is going to be running Linux. There's very few that are not going to be running Linux, and for them not to have an open source driver is just crazy. And this is a big problem. A lot of GPUs actually have the HDMI support on the GPU because that's where the codecs live and stuff. Anyway, so public access to the spec. This is not a new problem. The spec, public access to the spec has been an issue since at least 2021. If you want to read about that, it's kind of disappointing though. And then Linux on Mars. So last time I talked about the poor little Ingenuity, the helicopter on Mars. It broke its rotors and it's now just kind of dead. And you can see the picture of it there. It's on a sand dune and it's got broken rotors. But here's the interesting thing. It actually continues to collect data. So the camera still works, the processor still works. Well, we think it does. Here's the thing. So, and it has temperature sensors and stuff. So they're using it as kind of a little mini weather station. It wakes every day and it takes the temperature and it takes a picture. I don't know if it takes a picture every day, but it takes temperature data every day. And the problem though is that the rover, right, it had a Zigbee connection. The rover is not close enough for it to receive any of that data. It can't communicate with the rover anymore. The rover has wandered off and is doing other stuff. But it has enough flash storage. It has enough storage on its flash drive to store years, apparently, of data. And so if the rover ever comes back, it can collect all that science data. So, or, you know, in 30 years, maybe a human can go pick it up and get the flash drive. But anyway, that's interesting. But check this out. I was talking to the people at NASA, and one of the things that people don't talk about is there's also Linux on the rover itself. So the main operating system on the rover is not Linux. It's like Vertex or something because it's running on a rad hardened processor, and it's a long story. But they made this wireless base station that was the base station that talked to the helicopter. That was its only function. And it had the same, it had a Qualcomm processor. It was basically a copy of the processor that was on the helicopter because it was easier. But that processor is still there. And it turns out that processor, it's a Qualcomm processor, it's faster than all the other CPUs on the rover combined. So NASA is thinking to itself, well, what can we do with that? That's interesting. And so it's like, well, we've got this super fast processor. We've got all these rad hardened processors that, never have errors or I don't know, they're radiation hardened, so they don't have problems, but they're running kind of slow, right? They're like a couple hundred megahertz or something. You got this, quad core multi-gigahertz processor with all this RAM and stuff, and they're going, what can we do with that? And it's got Linux running on it. So there has been a proposal at NASA to use this to do some location processing. I'm not sure the details. There's supposedly a paper coming out this summer that they can do some processing to improve the accuracy. Use that horsepower they've got there. So Linux is not dead on Mars. That's pretty cool. Just thought I'd share that with everyone. Okay, in terms of community, we'll just have a couple more minutes here and we can wrap stuff up. Just want to talk about two things real quick, just conferences and then the eLinux Wiki. So conferences. The big one we had recently in terms of embedded was Embedded Linux Conference. It was part of Embedded Open Source Summit, which itself was part of open or co-located with Open Source Summit North America. So you can look at the schedule there for talk descriptions and at this on the eLinux Wiki, we have the page with all of the slides and all of the videos. So you don't have to attend the conference to get the value out of the talks. And I mean, I listed, probably at least 15 or so presentations already, but there's a ton of conference topics that are not already, that I haven't already covered. So audio, uh, V4, video for Linux, clocks and power management, Apertus, Rust, DTS validation. You can read that whole list. Tons and tons of stuff. Go check out the page. There's probably something there that is useful to you. Or you can bookmark as kind of a reference. And then also, I gave a keynote, so don't miss my keynote. And we also have the closing game. In this case, I dressed up as a spaceman. So hopefully that's fun. I don't know if looking at the game afterwards is entertaining, but maybe it is. My keynote was about lessons learned from embedded Linux in space. I didn't call it that. I should have actually referred to space because it was space related. But it's lessons learned and kind of how to overcome challenges in embedded Linux. So highly recommended. Not to toot my own horn. So what's coming up is Embedded Linux Conference Europe. That is going to be part of Open Source Summit Europe in Vienna in September. It's going to be a little bit smaller this year, just 2 days and 2 tracks. And then there's an embedded micro conference at Plumbers. It turns out that Plumbers is also co-located, the same venue. So we've got Open Source Summit and Plumbers, both in Vienna, and then coming up later in the fall, in October, we have Open Source Summit Japan. And for those of you who are familiar with Open Source Summit Japan, that is a new date. They used to be like the first week of December. And so they moved it up about 5 weeks to the last week of October. So that's kind of a change. It's kind of messing up my travel plans, but I'll deal with it. I do plan to be at that one, so hopefully to see some of you there. And then at Plumbers, I'm actually one of the conference leaders for Embedded and IoT Micro Conference. So we're going to have a micro conference and talk about embedded and IoT. It's not, it's very short. We only get a half day to talk about a bunch of different stuff. The focus this year, I've kind of announced, is on boot time. I'm seeing all this activity on boot time. I think it's a good time to revisit that topic and maybe get some companies collaborating on this. I had a meeting this week with Collabora on some boot time tests to get into K-self-test. But want to talk about instrumentation, testing, different technologies for boot time, talk about time critical boot phase versus an ordinary boot phase. So splitting the boot up into 2 phases. And then how to do kind of standards for pre-initializing the hardware if you have your firmware initializing like your camera, so that by the time Linux finishes loading, the camera's already running, and how to do that handoff and stuff like that. So there's a bunch of techniques we want to talk about, parallel init, cache probing. So if you are working on that and want to come to Vienna or have something interesting you want to talk about there, please submit a topic proposal. The deadline is July 5th. That's next Friday. For this microconference. Other microconferences have different deadlines. Some are already passed and some are a little bit farther out. But anyway, so you've got a week if you want to come to Vienna and talk to other people about boot time. Then finally, the eLinux Wiki. So Linux Foundation hired Bill Trainer, who was the eLinux administrator. So he's now a full-time developer. Again, there's a lot of great material on there. There is some stuff that's out of date. I say this every time. We really got to go in and go clean that up. I'm looking for volunteers to help with the site. We do have an LFX crowdfunding site. So we have uh, actually that crowdfunding site has $10,000 in it. So we can hire some people if we don't have time to do it ourselves. We can hire some people to go clean up things or to do projects where they put some information out there. So if you have ideas on that, just let me know. I've been saying for like a year now, well, not a whole year, but like about 9 months that I want to get a working group together. If you are at all interested in getting into a working group to kind of help support that site, let me know, and I will start doing some kind of monthly calls on that. Um, so what conclusion can we draw from all this information? Well, overall things are just kind of marching along. So there's a lot of problems still to be solved, especially as new technologies come online, right? So there's a lot of technologies having to do with AI. Uh, what was it? I heard that have to be dealt with, right? So they have these weird co-processors, just like we have GPUs. I think you're going to see specialized AI processors. We're already seeing specialized AI processors. What do they call them? NPUs, neural processing units. And we continue to see kind of lots of issues with asymmetric multiprocessors and how to deal with those. And so, but in the end, embedded Linux is widely deployed and it's functional. There are literally billions of devices running Linux. And the core kernel systems are in place to support embedded. We have tool chains. Uh, we have, development tools. We have debug tools and instrumentation. But we'll always have things to write and to upstream. There's always more new hardware. There's always new drivers to write. And my question is, what do you think is missing to support embedded development? Is there something that I haven't covered that you think is important? Just let me know, and we can discuss that and get it on track to be discussed at one of our conferences or to have people in the community and industry collaborate on. This is a list of the resources that I use. I use LWN.net, obviously extensively. You can see from my links. If you are interested in the events, go to the event pages on elinux.org. And then also check out, if you want to stay up to speed with what's with events coming up, ELC events, linuxconference.com. Other than that, I will say, oh, and then this is a really good resource also. If you have a question about any particular topic in the kernel, be sure to use the LWN.net kernel index. This has literally 20 years worth of material, so almost anything. So like if you have a question about shadow stacks, right? There's a page on where just search on this kernel index page and you can find a bunch of articles that have been written over the years about shadow stacks. And that's true for almost every subsystem, all of the core systems, all of the drivers and stuff, tons of information that's just sitting there ready to be used. So with that, I will say thank you for your time and field any questions.
So any questions? I think I know Kobota-san sent a question to chat.
Oh,
so,
okay.
Yeah.
I have to get to my chat.
Thank you. Thank you,
Yeah,
Tim.
thank you.
Yes. The question is it says the venue of plumbers is the same as OSS EU, but the registration is different. Is that correct? Yes, that is correct. Plumbers and Open Source Summit are not the same event. They are in the same location. They're in they're right next to each other. The rooms are right next to each other. I don't know how they're dividing things. Also they only overlap by one day. Right. So Open Source Summit Europe is going to go Monday, Tuesday, Wednesday, and that has its own separate registration. And then plumbers goes Wednesday, Thursday, Friday. So they do overlap one day. But if you want to go to plumbers, you need to register for it separately. So that's a good question.
Yeah, thank you very much. Any other questions from this room or if you are joining this conference from the network, please raise your hand. If you can direct to ask him.
I just realized I never turned my camera on.
Hello.
Oh,
Hello,
thank you.
Tim-san.
Yeah, please.
Hello.
Hello. This is Nobuyuki Tanaka from Sony Group Corporation.
Hey,
So I
Tanaka-san.
have one question regarding CRA. So how do community engineers from each company feel about CRA? So very actively to do it or normal feeling or giving up?
Well, okay. So last year
Mhm.
there was a lot of concern because the CRA language that we had seen so far did not make any exceptions for open source. And there was a really, really big concern that it was going to impose all these burdens, all these obligations on open source developers who are they're volunteers and they don't they don't have a ton of free time. They're like they can't make a guarantee of like 24-hour response on a security incident as a volunteer. And so that actually I got to give credit to the European Union because that feedback was given to them and they changed the wording. So there are exceptions in the CRA for open source projects. I think most people are kind of have the attitude of wait and see to see what it's actually going to mean. It doesn't take effect until October, it's not supposed to. I don't know if it's taking effect. This one there's two going on at the same time. There's an AI legislation that just barely got approved and starts taking effect in 6 months, but that's not this one. So CRA, the cybersecurity one, I think it's scheduled to get adopted in October. And then it takes a while for the terms to come into play. From what I can tell, most people are pretty supportive of the need to have better security, but they are worried about the obligations.
Yeah. Okay, thank you.
So I think one thing that's going to happen is companies have kind of relied, I think they've over-relied on the community to handle all the security incidents. And with that open source exception in the CRA, the community can say, hey, look, we are giving you software, but it's always been under this license that has a big disclaimer saying we're not responsible for security incidents. We do our best, but it's not like we're not going to be legally liable. And so the companies under the CRA are going to be the ones liable. So as much as it pains me to say this, I think it's going to be like the Sony and the Samsungs and the end product producers that have to deal with the CRA requirements and not the upstream communities.
Oh, okay. Thank you.
Yeah.
Yeah, exactly. So thank you very much. And any other questions or comments? Yeah, please.
Thank you for your presentation. I'm Akihiko Takahashi in FSAS Technologies. I'd like to start by mentioning that I'm not good at speaking English and will be using a translation tool and cheat sheet. So our communication might be a bit slower. I appreciate your understanding.
Well, your English sounds pretty good, actually.
Thank you. Could you open the kernel, Linux kernel handling CV handling page?
Oh, yes. Let me go back there. Sorry, I got to get back to my. Oh, sorry, I got to see. Okay, this was the CVE handling.
Thank you. If you have any good ideas, please give me some advice. I am one of the victims who watches CVE and checks for vulnerabilities in existing products.
Yes, and so so let me ask you this. So have you seen the sudden increase in CVEs?
Yeah. Yeah. It's often not clear by reading the kernel CVE because other CVEs often describe what kind of vulnerability they are, but Linux kernel CVEs are written kernel commit messages only. So we don't understand just what kind of vulnerabilities are included.
Yeah.
Oh,
Yeah, so I'm going to go to this next page here. So if you look at this article on lwn.net, especially look at the comments. So the article itself is kind of it talks about the CVE process and explains why how they do the filtering but the comments are very, very interesting because there are some of the people from the distros actually got into the comments and were talking about um, this issues. So I am not a CVE expert, but apparently there's something called a CVSS or something like that. I could be getting the wrong, but there's something that kind of describes the attributes of the vulnerability and like gives you an indication of how severe it is and how and what systems it affects, or and how it can be activated. But the distribution vendors are talking about coming up with some way that they can share that CVSS information. If I've got the acronym correct, so that they can share enough information to reduce the workload. Because so they said, well, a lot of these are like, unless you like, if you don't have physical access to the machine, a lot of these don't apply. And so there's certain things that make it so that the CVEs are not critical, right? And so so that is, I guess, a discussion to follow, and there may be lists where people are talking about this stuff. So in particular, SUSE mentioned that they're starting to publish some of their security analysis. So that may have the information that you're looking for. Hopefully, a bunch of different vendors can get together and kind of work together to resolve this problem. I don't think that the upstream is going to change. There didn't seem to be. The person who wrote this article is actually one of the developers on the CNA team, the kernel CNA team. And it's only 3 people. It's Greg Kroll-Hartman, Sasha Levine, and I can't remember the name of this Tom Johnson. I know I don't remember his name, but anyway, there's only 3 people, and they're handling all of the patches, the patch queue, as well as the CVE. And it's a lot of work. So they really need the help of the distro vendors and anybody who's working on this to help kind of contribute that information. And CVSS was mentioned as one way that they might be able to share that information that would make it so right now people, because the CVEs were coming in at such a low rate, people were basically handling all of them and saying, well, we'll just make sure we get the patch to fix every CVE. But if there's too many, you can't, it's kind of too much. Although, the upstream, I don't know, the upstream people are always say, well, just take all the patches. Why are you picking and choosing the patches? So, but that's a whole other issue. So anyway, I don't know if that answer was helpful at all.
Oh, thank you for your a lot of advices. I will discuss after this session. Thank you.
Yeah.
Sorry. Thank you.
Yeah.
Thank you very much. And any other questions? We can have one more. Any others? All right. Thank you very much, Tim.
Okay. Thank you.
So see you in Vienna.
Yeah, we'll see you in Vienna. Oh,
Yeah.
Trying to figure out how to stop my presentation. So over here somewhere. There we go.
Right. So the next
thank-
present. Thank you very much.
Okay.